You are watching the 8.3 lesson video on solving systems graphically day 2. We are going to jump right into some examples today because we spent so much time last class talking about graphing. So we're just going to do more examples because practice is going to make permanent. Example number 1 gives us two functions, h of x and j of x. One is linear and the other is an absolute value function. And it says which value of x makes h of x equal to j of x. Now, we could go ahead and solve this algebraically if we knew how to solve absolute value equations, but we don't know how to do that yet. So what we're going to do instead is use our technology to help us. I'm going to graph these. So in my graph, I will, I already have it up, but you know what, we'll do this again. I'm going to add a graph, and I'm going to graph 1/2 x plus 3, and I'm also going to graph the absolute value of x on the same graph. And we can definitely see that the two functions are intersecting with one another in two different places. Now, you can change your window if you need to. I'm going to click and drag just so I can see the intersections a little bit better. But really, what I would like to do is find out those places of intersection. So remember, we go to Menu. I am going to use the geometry route because there are 2 points, and that saves me a little bit of time. I want to find a point, so select points and lines, and in fact, I want to find the intersection points. So I selected 3. And we need to select both graphs, h of x and j of x. Click both of them to identify the 2 intersection points, and on our papers we want to show this work of 2, 2, and also at 6, 6. Now you can see in the answer choices we don't have points. Well, that's because it says what value of x. So this is my x value for both of the points. So if I see either a -2 or a 6, I have the right answer, and number 1 is correct. Moving on to question number 2, it tells us to graph both of these functions, f of x and g of x, on the graph below. And then it asks a question. So in order to answer the question, we definitely need to show some work and or look at a picture. They told us to graph, so that's exactly what I'm going to do. So in order to graph these, I'm going to do them as 2 separate functions. So the absolute value of x, we actually just graphed this one. We can hit enter to graph it. And since I want to put this on my coordinate plane, I am going to show a table of values. Now, some of you might say, you know, I know what this looks like. This is the parent function. But if you don't, we can always use our technology to help us get a better picture. So this is the absolute value parent function. So anytime you put in a negative number, like -3, -2, -1, 0, anytime you put in a negative, you're taking the absolute value of that, so it makes it positive. Here's my vertex. We can see this repeating pattern of the y's going on over here. And hopefully, oops, that should be 1. Hopefully, I have captured what I needed to in this table, but if I haven't, I can always go back. So let's hide the table and add, let's add a new function. So we'll add -x² plus 6. This is g of x. Okay. Again, some of you might be able to graph this because you know it's a shift of 6 up and being reflected over the x-axis, but if you didn't know that, let's just get what we have graphed. And I'll graph the same set of points for g of x that I did for f of x, but if we need to put more on there, that's okay too. So if I want to graph -3, I could probably actually squeeze another one on there. Yeah, let's start with this. -4, -10, -3, -3, -2, 2, -1, 5, 0, 6. There is my vertex, and I know this because I can see the repeating Y pattern happening. So I'll have 5, 2, -3, and -10. And I did that without my table just because I was trying to match up my Y values. Okay, looking at the graph, where's the X and Y axis? Well, it's not there, but we need to draw it in somewhere. And this is kind of nice because we can put it wherever we want. Well, when I look at the picture, let's just hide the table so we can see the graphs better. My standard window is actually okay. So you know what, I'm going to put my X and Y axis somewhere right in the middle. And you should do that too. So use your ruler to put in your X and Y axis. This is where I put my X and Y axis. My Y axis is a little off to the side, but whatever, it's not a big deal, as long as I make sure that I always use the origin is where it's supposed to be. All right, I'm going to go ahead now and graph my f of x function by just plotting all of the points that I have in my table, but also I know what the rest of the points are supposed to be because I'm just going to follow the pattern for both because it has the same slope for each of these two sections of the absolute value function. And then of course we will use our straight edge to graph, and we also want to make sure that we label and draw arrows because they didn't restrict the domain. Okay, so there's my picture of f of x. Let's go ahead and do the same thing for g of x. And I just really like graphing my vertex first. Okay, so I finished graphing my quadratic function. You know, I tried to draw an okay graph, but look at, I missed this little section over there because those should be intersecting right at those 2 points. So here and there we can see our points of intersection. We can also see those 2 points in both of our tables here, showing yes, this indeed is the solution to this system. So we graph them, and then it asks us, does f of x equal, or f of 2 equal g of 2? Well, f of 2 is, well, we input 2. What do we get out? We input 2. What do we get out for both f of x and g of x? And is this true? Does f of 2 equal g of 2? And the answer is yes. And it says here to use your graph to explain why or why not. So how do we know this? Well, we're looking at the intersection point of 2, 2. So let's write an explanation. So I wrote down here f of 2 is equal to g of 2 because the two functions intersect at the point 2, 2. When x equals 2, y also equals 2. Moving on to question number 3, it says the solution of an equation with 2 variables, so 2 variables, x and y, is, okay, so before reading any of our answer choices, let's talk about what a solution of an equation with 2 variables, x and y, would be. A solution, remember, looking back to our lesson 1, a solution to a function is any point that is on the function or on the graph of the function. All right, so if we look at our answer choices, we should be looking for a point, or at least an x value and a y value together as a solution. Where if it would have just said the solution of an equation with 1 variable x, it would just be the number that makes x true every single time. But now we're looking at 2 variables, so we get an x and a y value. So answer choice 1 says a set of all x values that make y equals 0. Well, that's not true. Y might not always be 0. In fact, it probably isn't. And the same reason why number 2 is wrong, the set of all y values that make x equals 0, that's not talking to us about the points on the graph of the function. Okay, question 3. The set of all ordered pairs. Wait, what's another word for ordered pair? That's a point. So we're talking about the set of all of the points, and they told us x comma y, that make the equation true. Ding, ding, ding. We have found our winner. Moving on to question number 4, it says on the set of axes below, we need to graph two functions. One of them is a linear function, that's g of x, and f of x is a piecewise function, and I know that it's piecewise because it's in two different pieces. Okay, we should be able to graph this line easily. So let's graph the y-intercept is at 0, 1, and its slope is 1/2, which means I go up 1 to the right 2. So we'll plot this. We will use our straight edge. Remember to label. Remember to cover the whole graph, so we're going to go in the opposite direction as well. So there's my beautiful graph of, oh, I wrote f of x. It's not f of x. That is g of x. There's my beautiful graph of g of x. Okay, now I need to graph f of x. So f of x is a piecewise function of a line, 2x plus 1, and a quadratic, 2 minus x squared. I'm going to graph 2x plus 1 first. So let's graph that piece. That means I have 0, 1 is my y-intercept, and my slope is 2 over 1, so up 2 to the right 1. So here's my y-intercept, and I'm going to go up 2 to the right 1. And I will make sure to do this over my whole graph, down 2 to the left 1, so I can capture all of the points. And one thing that you should notice now, though, before, I mean, we could graph the whole thing. We could connect them with a straight line. But what I'm noticing right now is that my domain is restricted for x is smaller than or equal to -1. So I only care about all of those values. I don't care about any of those. And in fact, this point here, I don't even care about. So I'll make that blue again. Now I know that if it's less than or equal to, this is going to be a closed point here, and continue with an arrow because it's for all of those values. Next, I'm going to graph 2 minus x squared. Now, I know by looking at this that it's a shift of 2 up and a reflection over the x-axis, but if you're not sure about that, all you need to do is just graph it. Okay, so we can just add a graph and type in 2 minus x squared, and then get the table of values. Because it's a quadratic, I still want to see the work for the table of values anyways. So why don't I bring this down here? So we'll have x and f of x. And it's only over the domain from -1 on, so I can just use those points in my table. And I really try to make sure that I get my vertex in there as well, which it looks like we are getting that. There it is. So 0, 2 is our vertex. And I want to make sure that I get all the points that I possibly can plotted. Okay, so we're going to do this. I think that should just about do it. So let's continue on. And I'm going to graph -1, 1, 0. No, I put that in the wrong spot. -1, 1 is right here. 0, 2, 1, 1, 2, -2, and 3, -7. 7. Now I connected all of my points, but the last thing that we always want to be careful of is making sure that our points are open or closed and that we've used arrows when we're supposed to. So I'm automatically or immediately realizing that since this is x is greater than -1, I should actually have an open point at -1 because the closed point was down below here for the f of x function. And then x is always greater than -1, so this is okay that I have the arrow on the end. And let's not forget to label. Now continuing on, there is a little bit that we have to summarize down here. It says how many values of x satisfy when f of x is equal to g of x. Well, we can see that the two functions are only intersecting at one point, therefore there would only be one value of x that would satisfy when the two functions are equal to one another. Here's my explanation that one value of x satisfies when f of x is equal to g of x because the two functions only intersect at one point. I also just wanted to show you what this looks like on the calculator. You don't have to do that, but this is something that I would encourage if you have extra time to always go back and obviously check your work. We can see that the point is not at a nice intersection with integer numbers. In fact, it's some decimal values, but still it's only intersecting at one place.